Let's talk about the second model under the cognitive techniques. So, cognitive complexity theory is the next model after Gom's model. We can also refer to this model as a CCT model. CCT has two parallel descriptions, one of the user's goal and the other of the computer system, called the device in CCT. The description of the user's goal is based on Gom's structure, like goal hierarchy, but is expressed primarily using the production rules. This particular model makes use of the production rules, which can be of the form of sequence of rules saying if the condition is true, then perform certain set of action, where the condition is a statement about the contents of working memory. If the condition is true, then the production rule is set to fire. An action may consist of one or more elementary actions, which may be either changes to the working memory or external actions such as keystrokes. Here is an example of CCT, that is editing using a VI editor. So the production rules are in the long-term memory. The task is to insert a space where one has been missed out in the text. So for instance, if you notice that in the above paragraph we had written cognitive complexity theory. So if we write something saying that there is no space which is provided between some particular text, like cognitive competing theory. So in this case, if there is no space which is provided, so we are supposed to provide a space in between this. This is reasonably a frequent typing error, and so we assume that we have developed good procedures to perform the task. Consider the fragment of the associated procedure rules. Now here we can say that the goal is to perform unit task, the text task is to insert space. Now the text task is to be performed at 5:23. The text refers to the text of the manuscript that is being edited, and the cursor refers to the insertion cursor on the screen. The location is the 5th line number and the 23rd column number, and the current cursor position is at line number 8 and the column number is 7. The rules are pattern matched to the working memory as shown over here. There are 4 types of rules which we can see over here. So there are code fragments for 4 different types of rule. One is select insert space, the other one is insert space done, then insert space 1 and insert space 2. So the rule here which we can see are the 4 rules which can fire, but out of them only the first rule can fire. The condition for select insert space, this rule can only be fired. The rule fires and its action is performed. So what is the action which is supposed to be performed? So if this is a condition, some action is supposed to be performed over here. This action has no external effect in terms of keystrokes, but it adds some extra information to the working memory. The keystrokes for actually inserting the space, once you are at the right position, have been proceduralized over here. That is, the user does not go through the sub goals, enter insert mode, type space, leave insert space, and so on. So CCT has set a style of rules for novices. So here the active rules are, these are the ones which are possible. Out of them only one would be fired, that is select insert space, which is going to match the current working memory and it would insert into the new working memory with the one which we are supposed to perform. This is the code for the select insert space which is supposed to be fired once the rule is found to be correct, once the action is to be performed. So what does the CCT talks about? CCT has set of style rules for novices. These limit the form of conditions and actions in the production rules. The rules in CCT need not represent error-free performance. So, error behavior can be represented over here. They can be used to explain error phenomena, though they cannot actually predict them. The measures which they can find out depends on the depth of the goal structure, the number of rules, and comparison with the device description. It provides a parallel model and proceduralization of actions. There are some problems with the goal hierarchical model. They can be a post hoc technique which they are making use of, expert versus novice, which means that we don't know how good and how beneficial it would be for expert users or for novice users, and actually how cognitive they are. There is one more model which we are supposed to learn under this, which is an HTA model, hierarchical task analysis model, which we are going to learn on later in our syllabus. Next, we'll talk about the linguistic models. The user's interaction with a computer is often viewed in terms of language. So, it is obvious that several modeling formalisms have developed centered around this concept. Several of dialogue notations are based on linguistic ideas. So, we say that understanding the user's behavior and cognitive difficulty based on analysis of language between the user and the system. Similar in emphasis to dialogue models, they help in the similar way as dialogue models. So, two categories of models which we are supposed to learn under the linguistic notations are Backus-Naur form, BNF model, and task action grammar model, that is TAG model. BNF model is a representative of linguistic approach from BNF rules to describe the dialogue grammar. This views the dialogue at a purely syntactic level of a particular dialogue and ignores the semantics, that is the meaning of the language. BNF has been widely used to specify the syntax of computer programming languages, and many system dialogues can be described easily using the BNF rules. For example, imagine a graphic system that has a line drawing function. To select the function, the user must select the line menu option. The line drawing function allows the user to draw a polyline, that is a sequence of line arcs between points. The user selects the point by clicking the mouse button in the drawing area. The user double clicks to indicate the last point of the polyline. Okay, so for this particular application, we would say that the BNF model is going to provide us with some terminals and some non-terminals. So what are terminals? Those are going to be at the lowest level of the user behavior. For example, click the mouse or move the mouse. And non-terminals would be nothing but ordering of terminals. They would be at a higher level of abstraction. For example, they could be select menu or position menu. This is the example which I was talking about. So the basic syntax talks and says about non-terminal. They are defined as some type of expression. So this particular symbol is referred to as is defined. So non-terminal is defined as an expression. An expression contains terminals and non-terminals. An expression can be combined in sequence using a plus sign or as an alternative. For example, over here, if you can see draw line, here we are saying that it is defined as select line, then we have to choose points and last point. But select line itself is a combination of position mouse and then click mouse. Click mouse is the final action which is supposed to be performed. Choose points over here is defined as we can either choose 1 or choose 1 plus choose more points. So these are the ones which indicate the non-terminals, and the ones which are written in capital letters they do refer to as the terminals in case of BNF. Now there are some measurements with BNF. We would say that the BNF description of an interface can be analyzed in various ways. One measure is to count the number of rules. So how many rules are there? The number of rules, if they are more in number, it is not a very good thing. The more rules an interface requires to use, it is more complicated it becomes. The measure is rather sensitive to the exact way the interface is described. A more tough measure also counts the number of plus and or operators. So if there are more number of plus and or operators, it becomes more complicated. So there are some complications which are mentioned over here. Same syntax for different semantics. So it creates an ambiguity for the user, no reflection of the user's perception, and minimal consistency checking. A more tough measure, and this would in effect correct the complex single rule. So we must have the minimum number of rules and less complications in case of BNF. So under the category of linguistic models, we have the other one, which is task action grammar. Measures of this are based upon BNF and have been analyzed as not cognitive enough. So they are not categorized under the cognitive models but under the linguistic model. So talking about the language, they ignore the advantages of consistency both in the language structure and in the use of its command names and letters. Task action grammar deals with some of these problems by including elements such as parameterized grammar rules to emphasize consistency and encoding the user's world knowledge. So it makes of specific parameterized grammar rules. To understand what is task action grammar, let us recall the example of Unix commands, that is cp command and mv command, and one more which is ln command for linking of files. Each of these has two possible forms. They either have two arguments, a source and a destination file name, or have any number of source file names are allowed for the destination directory. So we can copy a file and another file, or we can copy the file to some other directory. So it can be either a different file or a location, or it can directly be to a directory, and same way for all three of them. Measures based upon BNF could not distinguish between the consistent commands and an inconsistent alternative. Say if ln took its directory argument first, so if the rules are supposed to take, instead of taking a file name, ln takes the directory, so what would happen? So the task action grammar was designed just to expose this sort of inconsistency. No BNF measure could distinguish between this and a less consistent grammar in which we have such sort of problems. So the consistency in the task action grammar says consistency of argument order is made explicit using a parameter or semantic feature for file operations. Feature possible values over here for copy, OP for copy, move or link. So this is a parameterized example or a parameterized rule which is provided for this over here for all the commands which are supposed to be followed in case of task action grammar. There are other uses of tag. It says that it makes of the user's existing knowledge. It provides similarity between features and commands, and these are modeled as derived rules because they are going to provide us with some sort of parameterized rules. Here we come to the end of the linguistic types of models. In my next video, we would be watching the next part of the next category of the models, that is physical and device models.